So here's a slightly trickier example involving direct collisions. Two smooth spheres of mass m kilograms are at rest on a smooth surface. In front of the second mass is a smooth wall where E is 5/8. The coefficient of restitution between the spheres is 1/3. Don't know why that's happened. The first mass is struck with a speed of 12 meters per second towards the second mass. Determine whether or not the spheres will collide for a second time. So there is a bit of logic involved here, and I'm going to leave that logic up to you, the viewer. And so when you're ready, come back for the solution after you've tried the problem. So here's the solution. I did actually have to make a few changes to this because a lot of the information was incorrect. But nonetheless, if we start with the principle of conservation of linear momentum, we get that 12 times m plus m times 0 equals mv1 plus mv2. So the sum of the velocities is 12. Now, of course, over here, v1 minus v2 is minus e, so minus 1/3, so between the spheres, times the initial velocity of the first, which is 12 minus 0, which gives v1 minus v2 is minus 4. Adding the equations, we get v1 is 4 and v2 is 8. So what will happen now is that both of them will be travelling in the same direction. So v1 is 4, v2 is 8. So even from this, they will definitely collide. However, proving this mathematically, E is minus v over u, so 5/8 is minus v over 8, so the velocity of the new one is 5 meters per second in the other direction. So what that would look like is a sphere hits the wall and then comes back this way at minus 5 meters per second. So because they're travelling in opposite directions, they will indeed collide for a second time.